when the crew not doing these kind of operational events, they are of course focused on all of the science taking place on board the station. And a recent investigation could lead to some new ways to protect robots in the harsh environment of space. Could also help create better prosthetics for humans on Earth. Our NASA colleague Lori Meggs sat down with Dr. Lenore Rasmussen to talk about how synthetic muscle performed on the space station.
What we learned is that it can withstand much more exposure on space than we had initially hoped for, in part because it was up there for over a year. It initially was going to be a 90-day experiment, but it came back on SpaceX 6 with over a year in space. And all the samples, it was a duplicate experiment on Earth, just like the twin study, but all the samples are intact. There's a slight amount of yellowing in some of the space samples, which can be indicative of accelerated aging, but as far as their material integrity, their what we've explored so far, this is ongoing in the chemistry and the electroactivity, they're working. So we're actually very happy with the results we have so far.
What were you hoping to find? What were we really looking for?
There were indications even before I began this experiment that these class of materials that these are in maybe inherently radiation resistant. And I had already, when I was back at Princeton, had done some previous extreme temperature conditions on the third gen materials anyways, where we took them literally down to between 2 and 4 Kelvin, and they took a while to thaw. Then they worked fine. So we said, well, if these were also radiation resistant, I said, yeah, these could be used for space travel. You could even dehydrate them and then hydrate them, when you get back.
So we would use the material for what in space travel?
You know what? They could be used for several things. They could be used for human assist on Earth and in space. A lot of the trying to move when you're all suited up can be very difficult, so that could be kind of almost kind of tied in as sort of an exoskeleton fashion, and also offer protection at the same time. These are force attenuating. My goal is to bridge form and function. Initially, what got me into this space was prosthetics, to make a lifelike, human-like hand, if you will, that was also affordable. This also has got, we've received a lot of attention in the robotics community, and for a lot of motions that we find very intuitively easy is actually somewhat difficult for a standard gripper, turning a knob and stuff. And whether it's on space, where there's it's a very challenging environment, we do want to explore that environment, and there are a lot of situations where you can't put a human.
So we would see then maybe a robot coated with this, made of this? What?
Could be a glove or an external device coated with this, where it's kind of assisting with the motion and also providing protection. That's the other thing I'm looking at.
From your background, you were looking at prosthetics and things like that, and then you have the opportunity to have a space station experiment. What's that been like?
I'm floored that we're using almost like military precision, but all of humanity is working together on this instead of against one another. So the collective movement and work and coordination with the truly international space station is just so rewarding and inspiring.